Welcome to the DIY Honda Garage channel. This presentation covers DTC P0221, indicating that the throttle position TP sensor B output voltage is out of the specified range, leading the powertrain control module, PCM, to store this Diagnostic Trouble Code, DTC. The TP sensor is crucial for monitoring the position of the throttle plate within the throttle body, allowing the engine control system to manage air intake effectively for optimal engine performance. When the output of TP sensor B is less than 0.48 volts or more than 4.61 volts, it signals an issue that must be addressed promptly to prevent reduced engine functionality or potential stalling conditions. During this troubleshooting guide, we'll investigate the components affected, the symptoms you might notice, and the steps needed to diagnose and resolve the issue, depending on our findings with the Honda Diagnostic System HDS. We'll also make reference to inspection procedures and detailed information for efficient troubleshooting. Let's proceed with understanding the key details about this issue and how to effectively resolve it. The error associated with DTC P0221 indicates a malfunction of the throttle position TP sensor B, which is directly integrated with the throttle body of the Honda CR-V 2023 Plus. This sensor's primary role is to measure and report the position of the throttle plate to the powertrain control module, PCM. This information is critical because it helps the PCM adjust the air-fuel mixture for proper combustion, thereby influencing engine performance and responsiveness. The TP sensor B's location within the throttle body enables it to accurately measure throttle opening angles. The sensor generates a voltage signal that the PCM monitors. If this voltage goes below 0.48 volt or exceeds 4.61 volt, the PCM recognizes these values as out of range and records the DTC. Understanding the role and position of the TP sensor B is vital for effective diagnostics and repairs. The possible causes for DTC P0221 can be broken down into a few main categories. Firstly, a faulty throttle body could be responsible. If the throttle body itself has defects or wear, the TP sensor B may not function correctly. Secondly, there could be issues with the wiring or connectors associated with the TP sensor B, such as wear, damage, or corrosion, leading to poor electrical connectivity. This can cause the TP sensor's output voltage to drop or spike erroneously. Lastly, a malfunctioning powertrain control module, PCM, could also be the cause, particularly if other inspection items yield normal results, indicating the PCM may not be interpreting the TP sensor signals correctly. Each of these factors must be evaluated during the troubleshooting process to identify and rectify the issue effectively. When DTC P0221 is present, various symptoms can affect the vehicle operation. You might notice reduced engine performance due to improper air intake, leading to inefficient combustion and sluggish acceleration. Additionally, engine stalling may occur, especially under load or during acceleration, as the PCM struggles to maintain optimal air-fuel ratios. It's also common for warning lights, such as the check engine light, to illuminate on the dashboard, alerting the driver to a potential problem. These symptoms underscore the critical need for a timely diagnosis and repair, as they not only affect driving comfort, but can also pose safety risks. Understanding these symptoms is crucial for technicians in pinpointing the issue and providing resolutions that restore optimal vehicle functionality. The first step in troubleshooting DTC P0221 requires turning the vehicle to the on mode, ensuring the electrical systems are powered while not starting the engine. By utilizing the Honda Diagnostic System, HDS, the technician will focus on the TP sensor B's voltage output. Specifically, You're looking for the voltage to fall within a specific range. If it registers below 0.48 volts or above 4.61 volts, this confirms the failure and reproduces the error condition that the PCM has logged. By conducting this preliminary check, you can determine whether the sensor itself is functioning properly, or if subsequent components need investigation. This step is crucial for establishing a baseline understanding of the system's health before delving deeper into the components and circuits associated with the TP sensor B. In this second troubleshooting step, the focus shifts to the throttle body. Begin by visually and physically inspecting the throttle body for any signs of damage, contamination, or wear that could impact its operation. Ensure the TP sensor connection is secure and free from corrosion, as any irregularities or inaccuracies at this juncture can lead to erroneous readings. Given that the throttle body integrates the TP sensor, it is crucial to ensure that both are working optimally. If abnormalities are found in the throttle body components, it would confirm that the throttle body is likely the source of the fault and would require replacement or repair. Document any findings here, as this will inform subsequent troubleshooting steps and the overall diagnosis of the system. The third troubleshooting step involves testing the external circuits linked to the TP sensor. Start by disconnecting the throttle body 6P connector and the PCM 80P connector to carry out a thorough inspection. During this process, ensure the integrity of the power supply circuit, VCC3, signal circuit, THL2, and ground circuit, SG3. Using a multimeter, you should confirm that there are no breaks in wires and that the resistance is less than 1 ohm, meaning there are no open circuits in these critical lines. If you find values exceeding this limit or a short to ground, a deeper investigation into wiring and connectors will be necessary to rectify any issues. This step is essential for ensuring that all related circuits are providing clean signals without interruptions, which is vital for the TP sensor B to function correctly. As the final troubleshooting step, attention turns to the powertrain control module, PCM, if all preceding components have been deemed in normal condition. The PCM stands as the brain of the engine management system, interpreting signals from sensors like the TP sensor B and adjusting engine parameters accordingly. If previous inspection results show normal voltages and circuit conditions, it's inferred that the PCM may itself be the source of the issue. Conduct tests to verify that the PCM is functioning correctly without any faults present. In certain situations, if all other elements are functional, replacement or reprogramming of the PCM may be required to rectify the problem. Ensuring the PCM operates smoothly is critical to restoring the vehicle's overall engine performance and response. After conducting all troubleshooting steps and performing necessary repairs, the final verification stage ensures that all issues are resolved. Confirm that any faulty components, such as the throttle body or PCM, have been replaced and that all related circuits have been restored to optimal functionality. Retest the vehicle to assess its performance under normal driving conditions, ensuring no new codes appear on the Honda Diagnostic System, HDS. This final verification is essential for confirming that the repairs were successful and the engine is operating as intended. Document these results for future reference, providing a comprehensive maintenance record. A successful verification not only gives you confidence in the repairs, but also assures that the vehicle is safe for use. Preventive maintenance is key to ensuring your Honda CR-V remains in optimal running condition, particularly regarding the throttle position sensor and throttle body. Regularly checking the throttle body for cleanliness and ensuring that it is free from carbon buildup or other contaminants can prevent premature sensor failure. Additionally, routine inspection of all electrical connections and wiring associated with the TP sensor can help catch potential issues before they escalate. Keeping these components well maintained not only extends their lifespan, but also ensures reliability in performance. Schedule these checks as part of regular service intervals to maintain optimal vehicle health and prevent the emergence of DTCs like P0221 from interrupting your driving experience. In summary, DTC P0221 highlights a critical malfunction concerning the Throttle Position Sensor B that necessitates careful and thorough inspection and diagnosis. Identifying and addressing the underlying issues associated with the TP sensor and related components is vital to restore proper vehicle performance. Following a systematic troubleshooting process can effectively pinpoint the cause of the problem, whether it lies in the throttle body, wiring, or PCM. Additionally, proactive preventive maintenance practices can play a significant role in enhancing the vehicle's reliability and longevity, minimizing the likelihood of similar issues occurring in the future. Staying informed and diligent regarding vehicle upkeep not only ensures safety, but also contributes to a smoother and more enjoyable driving experience. Please like and subscribe to the channel. See you next time.